Okay, hi. First in several lectures on videos on tests, and so this topic generally, the class has various background in this, varying backgrounds in this topic. So I'm going to approach this as if you have never seen any of this before, but we'll do it in a way that doesn't labor too much mathematically over it, and rather gives examples quickly, and we'll aim to understand this all eventually, rather than maybe more directly by going by defining everything in too much detail all at once, and examining everything in detail all at once. We'll define things rather quickly and then start to look at examples. So first of all, what is a hypothesis test? So let's give some cases. So cases where a test, we're just going to use the word test because it's shorter, might be used to, why is a test used? It's used to understand population parameters usually. So just like we assume generally in the previous chapters on estimation that a certain distribution is there underlying the data. And then our estimation, our estimators and intervals, they're on top of that assumption, right? That the data comes from a certain distribution. So in a similar way here, we're going to test whether, we're going to assume underlying distributions and test parameters for being certain values or in certain ranges. So it's very similar to estimation. So cases where a test might be used to make inference on a parameter, a population parameter. So in this case, we'll have it be P for an underlying Bernoulli P sample. Okay, so I have just made a couple up here. So one is we could say an election. We could have an election and say we want to know what percent of population would vote for A in election. Okay. This is the same as, this is equivalent to if we, what's probability a randomly selected voter would vote for A. Okay, so I can think of those both as wanting to make an inference about P in a Bernoulli P sample, right? So we could think of this as like, okay, well, let's hold off on that. We'll just leave this as a question. B, suppose we have drugs effectiveness, medications effectiveness. So say what percent of patients with some disease respond to the drug. Equivalent, what's probability? A randomly selected patient responds to it. Okay, it's another one. C, okay, we could have a complex game. So say we have a complicated complex game, like chess maybe, even. And we want to know what's the probability that A could be a player or a strategy beats B in a single match. Okay, so in all of these cases, I think it's reasonable. I think this is one nice reason to do this distribution first. It's reasonable to make the assumption that reasonable to model this as independent, as sort of they're binary, right? That's yes or no. I vote for A, I won't vote for A. I respond to the drug, I don't respond to the drug. I win the game, I don't win the game. So we can think of these as Bernoulli with a certain parameter P, probability of success P. And we already know an estimator for P is the sum of the samples divided by n. So that's fine. We can get an estimate for P. We can. Okay, so suppose though we want to know something. So we'll leave these. So let's maybe write a note here. So note. Well, each of these, each situation, right? Each case, each A, B, C can be modeled by YI Bernoulli P. Okay, so the question then becomes, okay, model. So the question then becomes, how can I make an inference about P? So question, we have at our disposal, say we have Y1, Yn is a sample from such a Bernoulli P distribution. What can I say? What can I say now? We could make up anything. Make up very different ones, some simple, some not so simple, but I'm just going to put a concrete test down here to get us started. So what can we say about likelihood that P is about likelihood that P is, say, greater than 2/3. Maybe it's the voting one, and I need more than a 2/3 majority to vote something. So, okay. Well, one approach is I would probably take the estimator here use this and and then determine the likelihood that P was greater than 2/3 based on that sample. This is pretty similar. This is pretty much what a test is going to do. I mean, there's nothing really new mathematically. It's a different way to set up these inferences. So what we'll do now is write down the test approach. So hypothesis test approach. So okay, so this approach works as follows. I always have 4 elements to this, and the first 2 are to write down the hypotheses. And it's kind of important how we do this. So if I want to argue that P is greater than 2/3, sometimes it's not always matter, but suppose I want to show that P is greater than 2/3. Then I will make that my alternative hypothesis. So I'll have HA P greater than 2/3. I call this the alternative hypothesis. Before that would come something, a set for P that is disjoint from that set. And you could just complete all possible values here and say P is less than or equal to 2/3. So here I have my null hypothesis. Here's my alternative hypothesis. Okay, in this case, this is called the null hypothesis, and this is called the alternative hypothesis. Okay. Now, usually we want the equal sign to be in the null hypothesis, so something to look out for. I won't even write it, but well, I think maybe it is important enough to write. So usually the equal sign is in H0. Reason for this you'll see in a minute, why we would probably want to do this. Okay, so, I'm not sure if I have a 2/3 vote or at least 2/3 vote. I'm going to sort of make my baseline that I don't. Okay, and the idea is I want significant amount of data to make my case for me, to say that it is greater than 2/3. So the idea is I start with the null, and I'm going to be safe and keep the null unless there's significant evidence from data to suggest otherwise. So I have my 2 hypotheses, and how do I make a test? How would you make a test? Suppose this is about Congress or something. I don't know how many hundreds of people are in Congress nowadays. 500? So a lot of them. We can't ask everybody, but say we can ask 12 people randomly. How would you, based on the polls of those 12 representatives, how would you determine whether 2/3 of Congress, or more than 2/3, would vote for A, say? Okay, think about that and click on the next video.